Hello, everyone. Welcome to today's webinar, 5 Steps to Optimize Your Assembly Line with Digital Workflows. My name is Jen Diamond. I lead product marketing here at Tulip. So first, before we get into the presentation, I just want to give a little bit about Tulip. So Tulip is a frontline operations platform that empowers companies to improve their frontline workforce productivity, the quality of their output, and the efficiency of their operations. With Tulip's no-code platform, companies can empower those closest to operations, so the engineers and the managers, to digitally transform their processes, guide frontline workflow workers, and gain real-time visibility into the people, tools, machines, and processes involved, all in a matter of days. Today, we'll be talking about the 5 stepping stones for optimizing your assembly line beyond just static work instructions. But before we get started, I do have a few housekeeping items. For any questions that you may have during the presentation, please be sure to post those at any time in the Q&A tab at the bottom of your screen or to the side. We'll be answering questions at the end during the Q&A session, and we'll also follow up to any questions that we can't get to via email. And lastly, a common question that we get is about recording. So we'll be sending the recording of the webinar along with some valuable resources that you can reference at any time and share those with your colleagues. So those will be sent via email after the webinar. So today I'm joined by my colleague, Sebastian. Sebastian Lorendell has 10 plus years experience in MES solutions for discrete, process, and pharma industries, as well as expertise in solution development, technical leadership, and pre-sales engineering, as well as proof of concept. So here is our agenda for today. First, we'll do a quick introduction to digital work instructions foundations. Then I'll hand it over to Sebastian, who will go through the 5 stepping stones. And then we will conclude the presentation with a few real-world examples and a demonstration of what a fully realized discrete assembly digital workflow solution might look like. So for a long time, people have stayed at their manufacturing jobs for years or even decades, and they become experts at what they did. And we see that across a lot of manufacturing industries. This is starting to change, as you've heard about, like the great changeover, I think it's called. And that's where like a lot of people are retiring and they're leaving with their expertise. And then at the same time, we have a lot of younger people, tech savvy, and they expect intuitive next-gen solutions. 2 years ago, I would have stopped the list there, but of course we've had COVID. And so with the pandemic, we've seen a lot more changes, from higher employee turnover to labor shortages, to changing demands and limitations to who can actually be on site. So to address these problems, the basic digital work instruction solution needs to have a few requirements. So the first one is capturing expertise and getting people up to speed quickly. So this is a requirement that is a reflection of the retiring experts and then also the next generation of new users and employee turnover. The next one is dynamic, streamlined for experience and productivity. That goes back to number 4, and then also number 6. Capturing data for tracking and visibility, that's important for all of these, but it's especially useful for kind of figuring out how to optimize the work instructions. And then also easy to update and adapt is really important for changing demands that requires agility. And then lastly, remote assistance and real-time feedback, that is especially important with number 7, where we're seeing that again and again, where people can't be on site, but they want to be able to get that real-time assistance. So what can go wrong and what can go right? For what makes digital work instructions sustainable? So we found through talking to a lot of people that work instructions, they get out of date really easily. And if they're out of date, they're not useful. So it's really important to have a solution that is easily editable. And then also it needs to be interactive and engaging for people, or else your operators are not going to actually use the instructions. Another thing that we see is that work instructions aren't based on skill set, and that results with bulky workflows where they become a nuisance for operators. So for instance, if you have somebody that is just starting out, that has been at the company for a month or so, they have to have a different set of instructions than somebody that's been there for 5 years, because the person that's been there for 5 years is going to get really frustrated that they have to go through each tedious step, and they don't need the same amount of information as someone that has been there for a month. And then lastly, for potential downfalls, multiple screens for entering tedious data can be like really tedious and become a time suck, and it can be like confusing and a source of error. So this is what a digital workflow solution would look like. So you have different instructions on the left there. So it's based on like the right instructions at the right time. So based on the product that you're building or the line that you're at, you'll have different instructions. It includes multiple steps, which is super useful when you have really complex tasks. And then also you can embed images, schematics, videos into your apps to make them more interactive and more useful for folks. So for the being able to edit it, there are a lot of solutions out there. This is Tulip, but basically you can have different screens for different steps. You can embed video, CAD, and other things, and it's a drag and drop kind of experience where it's really easy to build new things. You can also do a lot of like formatting and transforming objects, adhering to your company branding to make it really easy to use. And then finally, you can also easily define triggers to streamline next steps. So for instance, if you were clicking, oh, make a note, you can make a note, and that will direct you to like a place where you can take notes about what's going on in your process. So there's a lot of flexibility there. And you can do all this without needing to know how to code, which is great. So before I hand it off to Sebastian, so we've talked a lot about like work instructions that are like very basic. For the next part of the presentation, going to be talking about 5 steps to optimize it. And the question is, why optimize the assembly line with digital workflows? And there's a few different options. So the first one is, as I talked about before, doing more with fewer people on site and fewer resources. It's error-proofing to reduce expensive waste and preventing downtime, which can be really expensive, and making decisions with real-time data. So I'll hand it off to Sebastian, who will complete the rest of the presentation.
Yeah, thanks, Jen. So yeah, let's move on to like, and we see from the poll that some of you do use these digital work instructions, but some people are using paper or PDF. So let's see how we can take to the next step of first creating like digital work instructions and then move beyond this with like more connectivity, right? So let's look at the different 5 steps that we have in list and we'd like to take you through today. So we'll move to the next step. Okay, so we'll go through those 5 steps. So the first one is using data, collecting data to gain production visibility, right? So that's capturing data and making it available to everybody inside the plant throughout the shop floor and also for managers and even C-levels. Connecting edge devices, we'll talk about this as well. So collecting data from machines or from sensors, how we can use like digital applications to connect those different siloed systems. So we know sometimes communication between the business and the shop floor is like hindered by different solutions. So let's try to bring all the data together to the operator, for example, and improve communications and like maybe trigger alerts. Then we'll talk about like new ways of displaying the data, right? We're not just limited to computer screens. Like today, there's more available devices that can be used. So we'll talk about tablets, we'll talk about headgear, like machines. And then finally, we'll talk about vision that we can use to provide real-time feedback to the operator and also collect process data, right? So we'll first start, we look at all of those 5 and then we'll have a demo, but we'll start first with looking at collecting data for visibility. So if this is something that you're interested in, let's start about a few questions, right? That can help us understand what's needed and what's if it is the right step for you, right? So let's look at today what you're doing. So what data are you collecting right now that you and what data are you missing? So you might have, some of you do have digital work instructions already. Some of you rely on paper. So you're collecting data. So you're collecting data through paper, for example, like starting of operations, completion of operations. You might be using Excel to capture some of the data. But if you had like a screen on the shop floor, maybe available to your operator, you could be tracking this information live using some like work instructions or more advanced digital work instructions. How can you incorporate the data collection into the workflow, right? So same thing, if you have some digital work instructions, you have a workflow outlined already. Let's take advantage of this and add some extra data collection on top of it, like basically maybe start and stop time. So you're starting a work instruction step, and you also tracking the completion of that step. So now you already can capture the cycle time of the operation. So that's already visibility here. What KPIs do your business rely on, right? So probably some first pass yield, like quality KPIs, just adding some like tracking good and bad parts through a digital application is a way to get quality, right? And collecting start and stop time is a way to start capturing also like your cycle time and like your process performance time. And how is that data gathered and presented today? So we'll look at afterwards, but like dashboards, right? How do you visualize this data? We can create dashboards pretty easily. That's something that this kind of solutions can provide. In the end, what we want to get to is like provide the whole team full visibility into historical, but also real-time data across the teams, right? So different teams in the organization can visualize those reports across the different lines in your shop floor and across the enterprise. Once again, from the operator that needs data all the way to executives to be able to see what's happening with the business. So let's take a look at how that can look, right? Like what's the kind of dashboard we can build once we've collected that data. So here is an example of a dashboard here, so that to show production visibility. The example here shows like audits dashboard, but you could replace the term audit with work order, for example, with defects, with whatever data you want to be capturing. So we have here customized, like we can create customized dashboards that shows real-time data, operational data, and even like prepare printable dashboards. We're monitoring the production status. We're monitoring cycle times, right, through the data that we've decided to capture, right? So based on what you want to capture, we can monitor different kind of information. That data can be organized in different ways, so just standard charts, tables, but also Pareto charts, as we have some examples here, or just like KPIs, right? And so all those KPIs, which we can see here, for example, for these audits, we can see on the left which audits are past due, for example, 17 past due, 17 that are like behind. So this can help us identify and solve like production disruptions or issues that are about to happen and be able to just like tackle them faster, right? So you can see them coming, you might be able to see some trends and be able to analyze it. So data can be connected like from machines, can be connected from like also legacy machines that might not be necessarily like connected to the network today, that we'll talk about this in the next step. And also like from human input, right? So once again, that's where we started with a work instruction that's already offered to the operator, like digital work instruction. And by just adding a bit more logic to those work instructions, for example, like using a no-code environment like Tulip, you can advance this to start collecting that data and creating those reports. So that's how like you can start gaining visibility. The next piece, so we talked about like the connectivity, right? So you can connect your operators to a digital tool, like enter data and create those reports. The second way is to connect edge devices, machines, and also sensors. So today, if you look at your shop floor, like what are the machines that you have that you'd like to integrate with the workflow that you might have today, tracked with your work instructions or with any kind of solution that you have running for your operators, or that you'd like in your ideal digital solution for the operators. That could be to capture data automatically or just to trigger alerts, right? For everybody, once again, to have the visibility of what's happening with your machines throughout the shop floor. Do you have a way to gather data today from those machines, right? So do you have, maybe if you're talking about industrial machinery, you might have PLCs, you might have a PLC concentrator gathering that data, you might have OPC servers, maybe you don't. So we can talk about this, or maybe your machines are not connected, and so we can think of a new way or a different way of connecting those machines through IoT sensors, for example, and like kind of enhancing some of maybe those old machines that are too old to have any kind of connectivity. As an end result, we'll be able to, like with all that data, we'll be able to monitor and control the machines, the devices, to augment the frontline workers, right? By once again bringing the information to the frontline worker and gather that process data. So let's look at just like examples of some of those devices that could be that we can connect, right? So I have a whole list here, and talk about what this kind of devices can bring. So first, foot pedals and push buttons. For example, that could be if you have the work instructions to improve the operator's connectivity with those work instructions. You can just use those as a way to just like move automatically through the work instructions, right? Like not have to let the operator reach out for the screen, which can be like hindering their process, slowing them down. And also sometimes it's like it makes it like more difficult to get like operators buy-in because there's so much interaction with the screen. Scales, scanners, printers, those devices that are probably around. Scales can be connected, like some USB scales, to maybe retrieve data and like store it into a database for tracking, but also for quality purposes. Scanners and printers can be used to track your products throughout the shop floor, right? So you can scan a label, fix it on a product, and then you can track that product throughout the line, so you know at every time where the product is. Visibility again, right? We'll show example of this during the demo at the end of the presentation. So humidity, temperature, pressure for like room monitoring could be useful for like process trends. Vibration and current sensors could be used to enhance some like older machinery that has no connectivity. A current sensor is a great way to see whether the machine is being used or not. A vibration sensor is a good way to see, like, to do some kind of maintenance planning, saying like if the vibration is augmenting, maybe there's something wrong about this machine, and we need to send the maintenance team. Proximity sensors, photoelectrics, like for visualizing what's utilization. And downlight, which you probably already have all across your shop floor, can be connected as well to your operators interface, right? So that they can trigger some alerts, so everybody's aware that maybe a defect was generated by an operator through the digital application. Pick two lights interface there. We'll have some examples of this in the video. Vision, we have a whole session dedicated to this, and this networked machine we talked about earlier can be connected as well to gather utilization, viability of the machine, performance of the machine, OE, and so on. So yeah, let's move on to the next step. Then I think that was a good overview of what can be done in terms of connected machines. So connecting machine is very useful, right? Collecting data. Connecting like different systems also, right? So we have, like, you probably have those different solutions, your ERPs, your quality systems, your MES, your like all those different solutions that are today available to you, but they're not necessarily working together or connected, right? So let's talk about how we can connect those to improve communications and maybe trigger alerts. So what you might want to think about is like what the information is your team like needed like to perform their task, right? So what your operators on the shop floor, what do they need? They need a work order. They probably need the bill of material of the product that they're working on. They might need material specifications, test plans, all of this, right? And this might be available in different systems. So where are we pulling this information from? So talking about ERPs and bill of material, probably an ERP solution, but you might have data in your PLM solution if you have one. You might have like some, once again, test quality. You might have homegrown systems as well that you'd like to interface with. And the next step, which is like in the same area, just like slightly different, is that how to communicate within the team, right? So you probably like now, if you start adding more logic to the application that you share with your operators, you might want to exchange that data within the team, right? It's like triggering alerts, triggering notifications from machines, from operators, and how to bring this all together. So this will allow your workers to complete tasks faster by gathering data from different solutions and bringing the right data at the right time, and effectively, and like in one streamlined workflow, right? So all the data is like going one stream, where everything is connected, and allowing to communicate with multiple systems and multiple groups within the organization. So let's look at examples of what that could look like. So here we have like a single terminal interface, right, that brings context relevant to the operator. So it's kind of the idea of this frontline operator worker with one UI that gathers data from different solutions, so the operator has all the right information to make the perfect decision, to take the perfect decision, and also save time, right, and improve quality. So here on that screen, you can see the example here is a weigh and dispense dashboard or screen where the operator can visualize the work orders that are to be worked on, and then we'll bring more data to tell them exactly what needs to be done for each work order. So the way it would work here is like you can connect to, for example, like ERP solutions here, being cloud or on-premise, depending on what you have. So you have like NetSuite, for example, Microsoft Dynamics, SAP, whatever ERP solutions you have could be connected. You can even connect to maybe Google Sheets where you have some information. Nowadays, people rely a lot on this, or on the Microsoft Suite as well. Those can be interfaced to retrieve data and display it at the right time. And you have bi-directional communication. So you retrieve data at the beginning, but maybe once you've completed the task, you want to be able to update your ERP. Say, okay, I did my WAN dispense. I consumed that amount of material. Please update the inventory. Please update, like, let the business teams know that this task has been executed. So you can have that bidirectional information. You can pull data such as those work orders we're looking at now, bill of material information to know what's to be done, specifications we talked about earlier, or at the end of the execution, or we can maybe also like exchange shipping information, right? So those are the kind of things that you can do, and those are just some ideas. You might have completely new system, different systems that can be connected, and this is where creativity will be very useful as well. So then let's move to the next step, which will be talking about connectivity, communication within the team or within the organization. So here the use case is how to just exchange data, right? So first there was how to get data and be more effective about with our work, right? That's required of us. Here is how to exchange data between the different teams. So we have here an application where you can see an operator can enter, register an event, right? So they might have detected a defect. They want to send an end-on event so that people are aware of this. So we can pick the reason, right? So we can collect information, we can collect text and comments, and then send this kind of and then generate a new event. That event can be visualized by other operators then through the digital solution. That same solution will exchange data with other operators. But we can also maybe rely on some of the tools that you're using within your company to communicate, right? I mean, the business team, the engineering team, usually is relying on some communication tools like Slack, like maybe some of the Microsoft team, like Teams or Google. And so we might want to use this to interface and just send a message through Teams to a team in engineering and give some feedback on the product, for example. This allows to communicate, but also keep track of what's going on the shop floor. So here on the right side, we can see we have context about the station we're working on. So once the operator is declaring that end on, at the same time we know on which station it happened. So we can keep track of what's happening on each station, what's the current status. Those requests can be managed and the events can be reviewed. You can start a whole process, right? So either within the application here or through, I'm running out of time, or through other solutions. Let's move on to the next step, which is going to be talking about how to display information. So we talked about collecting data, how to display it the right way now to the operator, right? So let's talk more about the devices themselves. So here you might not, let's look at what you have on the shop floor. As you're going through a digital transformation, obviously that means deploying some hardware on the shop floor. So maybe you have some hardware, some devices, some computers and so on. Maybe some of them are already available on your shop floor that you can take advantage of. But maybe they're not needed, right? You might not want to go into that job of having to deploy hundreds of screens, one at each station. Maybe some of the operators don't even need a dedicated screen at a computer, at a machine or at a workbench, right? Some of your teams might be able to rely on mobile devices. Do you need some of can even those mobile devices work for some of your operators? Maybe they need to be hands-free, so you need to find some more creative ways and of displaying the data and giving them access to the digital work instruction and the whole suite of manufacturing applications. So what we want to do here is create displays that are helpful for the operator and do not hinder our task, right? We want to let them to stay as effective as possible. So here are different ways of bringing data, and it's not rocket science here, right? It's everybody knows about this. So obviously we have standard computers with touch screens. These touch screens are very useful to help operators really be interactive with the screen, and it's much easier than just a computer and a mouse, obviously. But we also now have phones and tablets are available everywhere, and most modern applications should be able to run with those. The advantage of those is that with built-in cameras, for example, you can think of your operators your maintenance operators, your quality operators going about the shop floor and looking at the problems that they saw and collecting information, writing down information, taking pictures, right? So all of this will help capturing more data, being more reactive, and so on. And then the third step, like machines, right? So I want to talk about machines really quick. We have also machines, right? So today, like machines are more advanced. You might have Windows running on some of those, or in our case, we have also a partnership with DMG Mori where we can show, we can run our Tulip applications, right? So this limits the number of screens instead of having multiple screens at one station, which can be also makes things more difficult for operators. Concentrating all the data into one single screen, so making their life easier. Then let's talk about the next step, which would be using, like, for operators who need to be hands-free, right? Who cannot really be bothered by a screen. Can think of something more advanced, like using like headsets, right? So those headsets will allow you to display work instructions, right? Like on like in a little box right here, so you can visualize the work instructions still, but also interact with it using like the advanced voice recognition. You can actually, in this case, like trigger the report here, and we see on that screen, you have that report button. You can just say, hey, I need to start a report, and then start like listing the comments, taking a picture, and all without the use of any hands, right? So you can, if you need to be working with the product and cannot really get your hands free, this is another solution. All right, so then let's move on to the last step, which is vision, right? So here we want to talk about how we can use like advanced vision to monitor the product, monitor the process, collect data, and give feedback to the operator. So we'll have some example in the demo as well about this to help understand like how this can be used. But maybe you have ideas of where like today cameras can use like capture the process and where it can be useful for your process. Where do you wish you could give your time like real-time feedback? So like where like you might know that there is some issues, like some maybe quality issues, and you want to be able to quickly give them some feedback, so like to improve quality, improve compliance to the product. How do you track and visualize the materials in the products, in the products moving through the operations? So you can use vision as well, like visual detection, to see product moving, entering, and exiting a station for more visibility as well. So in the end, that will allow us to improve the process speed, right, by limiting interaction with the application, also improving the quality by integrating those work instructions that we talked about, some real-time feedback from those work instructions and applications, and the data collected from vision, and adding all this to our operator workflow. So let's look at a few use cases for work instructions, and then I'll give the hand back to Jan. I don't know what happened. Okay, so let's talk about those work instructions use cases. So here we have a video. So the way vision use cases. So today, with the advance of AI and those technologies, we can use just off-the-shelf cameras to start with like vision capabilities. So here we have an example of a use case of tracking production. So we can track material as they enter the production station, and like here in this case, by monitoring a cart that has some jig stickers on top of it, and so the camera is able to recognize it. This will trigger work instructions and then like tell the operator what to do, right? So then the operator is loading those pieces into the tray, and then so we can like also detect the cart moving out of the station and then completing the operation. We can also use vision in this case to like track the quality and document the process, right? So we can take a snapshot as the product moves through the production and detect potential missing parts. In this case, if there are only 2 pieces instead of the 3 requested, the vision camera could be detecting this and give some feedback to the operator, for example. And we can also take a snapshot to document it, so that for compliance reason, you can come back and say, okay, we actually did perform as expected, right? We have a proof of this. Let's move to the next two use cases. So then another thing we can do is automating workflows. So you can see on that video here, we have an operator just speaking from a kitting area. And so we can detect a change here. So just like new activity or colors or something. Here we have those little like white boxes, which are configured through our vision capabilities. We call them a zone of interest, region of interest, and we can detect like a hand going through. And so that will like trigger some activity with the application, requesting the operator to pick the next step. And we can use vision at the same time to detect that the operator picked from the right bin or the wrong bin, right? And so we can use it to upskill our operators with that feedback. So notifying them when they use the wrong tool or pick the wrong from the wrong bin. And this is something that can evolve, like as Jen explained at the beginning, those work instructions don't have to be static. They can be based on the skills. So as your operators maybe have like more advanced skills, you could change this and maybe like have less of that monitoring, right? So depending on your operators, that's more or less needed. So that's I think that's a good overview of the different ways that you can add more technology to improve the like optimize your operations and go beyond what we call work instructions. Thank you, Jen.
Awesome. Okay, so I'll go over 2 quick examples really quickly. So the first one is RBW. So for the RBW, they're a relatively new company, and they were facing a scale up. And they came to us when they were having issues because they had hundreds of or thousands of SKUs and complex, highly customized assemblies, and it was really difficult for them to keep up with aggressive lead times and demands. So what they did is they connected they first developed work instructions, and they connected those to their ERP, which is NetSuite. And they were able to have an interactive, intuitive tool for exchanging information from their backend inventory and their production planning databases. And they also added in devices such as, you can't really see in either of these photos, but they included like scanners and other things as well. And by adopting the solution, they were able to get visibility that they needed to troubleshoot and optimize their process. And they were able to grow rapidly and scale more quickly. They're actually building out a new facility that they're dubbing the Factory of the Future, which will use a lot of Tulip and a lot of cool new technology. And you can read about it more on their website, but it sounds like it's going to be very cool. And then the next example is with Laerdal. This is very recent. It's very exciting. So they've been using our Tulip, they've been using vision technology to improve their kitting process. So at a new facility, they were going from a facility that was like used to kitting together all these or putting together all these kits for their CPR mannequins, and then they like moved it to a new facility, and so the new operators were having difficulty kind of learning every step that they needed. So they implemented Tulip, and they were able to track what they were taking. So you can see in the screen to the left is all the different pieces that they needed to put in a box. And basically the vision capabilities would track when something was added and when something was missing, and that gave them that real-time feedback that they needed to make sure that all the parts were in the assembled kits before they were shipped to customers. And as a result, they were able to reduce the number of defects reported. They reduced the number of shipments with missing parts to 0, and also they were able to decrease downtime costs and decreased production costs, or production time rather. So that's very exciting. 2 examples that we have here, and then I'll hand it back over to Sebastian to do the demonstration.
All right, thank you very much. So yeah, we'll go through a quick demonstration. We recorded some videos from our digital factory, so we can share with you examples of how to bring those different use cases we talked, and we just show you the examples of to like throughout a whole production line, right? So we can move on to the first step. And just for you to know, so this is done in our digital factory. You're welcome to come and visit us. We have like several of these stations around where we can show you how those edge devices and our edge devices and applications work together, right, for like to support your operators and dashboard and so on. So we'll go through a few steps in the life of the operator, the life of the product. And so we'll start at the beginning of the line with a station clearance. So here you can see on the screen, you have a video that shows our operator completing a line clearance. And so you can see visual work instructions, basically, and the operator is asked to confirm each of them. So they run through that checklist to ensure that all the products and the material have been removed in that case. And at the bottom, if you can see, I don't know how well you can see on the screen, but like there's actually like some green numbers that are flashing. Those are room conditions, right? So temperature and humidity of the room. So we are capturing this through our edge devices, edge connectivity. We have just some sensors in the room that collect this. This might be useful just to capture process data, right? So that you can just visualize historical data and do some analysis. maybe you discover that some of the like bad some certain room conditions have a bad influence on your product. So you could actually add some checks on this and verify that the room condition is within a certain threshold to like start to allow to start production, right? So those are the kind of things that you can start doing at the beginning of the job. So at this point, the operator completed the station clearance, and now they will be able to start the work order. So let's move to that second step. So here, we'll select the product to build, and based on this, we'll display the right work instructions and the right bill of material. So you can see on the screen here, like first, it like the application asks, like, do you want to scan a barcode or do you want to select from a list? So you can use a traveler that was sent to the line to track, or you can just retrieve, like look at the list of work orders that might have been made available by an ERP solution, for example. So you can have control of what work orders are available at which line, for example. You can go to this kind of control and at one time. So the operator can pick that the job, will pull the guided work instructions based on the job, right? So based on the product, the instructions will vary. The bill of material will vary as well, so that information will be used for the next steps. We have like some specifications, like color, options of the product that will be available as well, right? And you can see this on the right. There's some information about the work order that's been picked by the operator. Those are all like orders specifications that will be used. Then the operator will confirm, just start the job, and then move to the next step. The next step then is like to integrate with some more devices, right? So here, like Zebra printers are used widely across the manufacturing world. So we have Tulip, like easy integration next to the no-code platform with those kind of printers. So it's like very easy to add like the trigger of a label. So here we just print a label that will be used to track the product throughout the line. So that will be affixed on the device that we're building here, on the item we want to build. So at every time of the production, every time of the day, you know what product is where, right? So once again, giving you visibility, and you can track all the historical data, quality or performance data, trends, and link it to that serial number or to that device that you're producing. So now let's move on to the first station. So here, the work instructions are asking the operator to pick a knob from that radio that we're building here. And so this information is once again based on the job that we selected. So here we want to build a knob with a red color. So the operator is asked to pick from the bin based on the job here. So you can see there's the work instruction that's telling what to do, and then we have like a pick to light system in the back. So you can see that green light telling the operator you want to reach out right there and pick that specific knob. The vision capability at the same time is present and is monitoring this, so they can alert the operator when they pick the wrong material, right? So this will allow to improve quality, making sure that they pick the right item. As the example that Jen shared before, this will might reduce the number of defects down to 0, because you're always constantly monitoring, making sure you're picking the right material at the right time. So we ensure here that the right knob is picked. Let's move on to the next step. So the fact that we pick the right knob still, let's say in our process, we've noticed that despite having that pick to there's a way that maybe in the batch that's available to the operator, knobs with the wrong colors are available. So we decided to add an extra check, not extra validation step here. So we're actually using a camera and vision color detection to make sure that the color is actually red, because maybe sometimes the operator picks from the right bin, but there's a blue knob in there, they didn't notice it. So vision can be used as well in here to improve, again, the quality of the product. So now we've really tried quality, we enforce this. Let's move to the next step. Once again, here we're asked to pick a new material. And vision is very useful technology. Here, vision can be used to, for example, detect that material is low in that bin. So when we detect this, we might want to alert the rest of the line, the rest of the team, maybe the inventory team. So you could actually trigger a request to another solution. But another thing would be to just turn on an end-on light. So everybody on the line is aware that there is a risk here. The line might stop because we're running out of material. And using connected lights, for example, it's very easy to connect those and just turn on the lights, just using a light that's just coming from Amazon, for example. Or you might want to reuse some of those end-ons that you already have on the shop floor to help you communicate with the rest of the team. So let's then move to the last step, And so this last step here is just like a final inspection step. So standard inspection would just be a visual inspection. So you can have this and have the operator like manually like register visual inspection or take a picture of the object to confirm, even use like vision for some inspections eventually. But what we decided to show here is how you can integrate with some of the like very simple like connected devices that are available today, like a scale, right? So we know that the expected specification of this radio we're building is to be of a certain weight. And so we can use our scale here to monitor that the weight that we collected at the end of the line is what is expected. So this is a very simple way to make sure that all the parts are actually present. So that's going to limit the risk of failure of the product when it's delivered to the customer. So completing like that step, we then like can complete the job, right? So confirm that the job was completely correctly executed. And so we can start updating all the solutions as we talked about, right? So we've been tracking information, so we have full visibility of the process, so we can review what happened. And we can also then at this point display it on our dashboard that we talked about at the beginning, or we can also update an ERP solution to say, hey, now the job is complete. You can update, you can communicate this with the customer. You can update your finance, so you're able to get that full traceability and full visibility, both in your manufacturing system, but also in your finance system. So that was a quick way to give you an overview of how to use this. I'll let Jen take you from here.
Yeah, awesome. Okay, so we're nearing the end. I just want to mention, if you have any questions, feel free to add them to the questions panel. So some key takeaways that we were hoping that you are able to take away from this. So digital work instructions are very powerful for future-proofing operations, boosting productivity, and providing daily experiences. For some instances, it might be okay to just use, basic work instructions like PowerPoint or PDF, but in a lot of cases, it makes sense to explore further and to further optimize your assembly with additional steps that Sebastian has talked through. And that will help streamline data entry, guide workers, and provide the right information at the right time, which is incredibly useful. And so we presented Tulip's frontline operations platform and showing how different companies have used it all throughout around the world to build digital workflows and integrate it with other systems. And then, of course, I'm hoping that you were able to see it in action just now with Sebastian's demonstration. So next, I wanted just to give a quick overview of Tulip. I know we just saw this with the demonstration, but basically, Tulip has native IoT, which Sebastian showed. It's a dynamic experience, so you can connect to other systems and bring in information based on that system. The really great thing about Tulip is it's a no-code platform, so that means that you can start small and grow it and expand it over time. So you could just start with basic digital work instructions and then add that functionality over time. You don't need it all 100%. And then press go live. Like there's an option to start small. Also, Tulip is GXP ready. So that means that we have customers have the ability to leverage history records, permissions, controls, and authentication throughout the process. We have an ecosystem, so you can connect it to other ERPs, other things for messaging and shipping, which Sebastian showed. There's a lot of flexibility also with Tulip, and this relates back to the agility and scalability. So you can structure your data structures how you see fit, and so that they align to your processes, not the other way around. Going back to the no-code thing, you can get to a faster time to value. And then finally, Sebastian showed, but we have computer vision, and you can set it up relatively easily on your own without needing special expertise or machine learning expertise. And then another thing, I know I just mentioned this, but with Tulip, so it really supports experimentation. So you can build your apps, use real-time process information from people actually running through your processes and your workflows, and use that and that feedback to continually improve it and make the solution better over time. And so if you want to get a personalized demo of the Tulip's frontline operations platform, there will be an email going out as a follow-up, so you can respond to that, or you can just go to tulip.co and request a demonstration. So we have a growing community and a ton of different resources that you can access for getting to learn Tulip. So we have the Tulip University, we have a community that's very vibrant. We have a library, which includes a lot of apps, app suites, templates, and examples, connectors that you can use to get started. And you can configure them to your process and whatever you need to do. And then we also have 2 podcasts, so Augmented and then Behind the Ops, which is interview style. So we're interviewing different people and hearing about how they've gone about this. Awesome. So thank you all so much for joining. So we'll move to the questions portion. And I see a lot of questions, which is great. So the first question here is, how do customers justify the investment, ROI in labor savings, improvement in quality? Do you have an answer for that, Sebastian?
So this is something we can definitely help with, right? So we have our team. Our team will help you look at your needs and define some baselines, and then come up with some calculations. So that's something we can help if you're not if you don't have this kind of information.
Awesome. I have a question here. So I use CAD files in my shop. Do you know if those are compatible with your system?
So in our case, so we rely on a cloud platform to display CAD files. So it supports most of the existing formats. If you have a specific format, feel free to send it to us, and we can verify it. But it's going to be translated to that cloud platform and then made available into Tulip.
Is there documentation on how this radio app works?
So the great thing with Tulip is that, as we're explaining, that using that no-code platform, you can build the application to tailor your process. So if the basic answer is that there's no, you start with a blank slate and you can build the application to your process. If you want to use to start with existing applications, you can go on tulip.co, and we have on the website an application library where you'll see examples of those applications. Not that exact one, because this one is tailored to a specific process, but you'll find applications for static kind of work instructions, dynamic work instructions. So you can look at those and how this is all configured. And then if there's more questions, we'll be happy to show examples throughout the demo of how this would work. But to remember that with Tulip, you have you have the full control of this throughout our no-code environment.
Awesome. And then next question, do I need a special camera for Tulip Vision?
So Tulip Vision works with any off-the-shelf USB camera. So you don't actually need any specific camera for basic vision. If you want some more advanced capabilities like depth, for example, we can recommend some cameras that will be needed. But for the basic vision that we show in the examples, just like any camera will work, like the webcam you used for FaceTime, for example, or whatever Facebook messenger you can use as well. Sorry.
And then also I just wanted to add, you can also use IP cameras. So if you already have those existing within your facility, you can also use that within your Tulip apps and using Tulip Vision. Awesome. Great. Can you share the URL for the Augmented podcast? I can. It's augmentedpodcast.co. So I can add it there as well. And then can I get an access to a recording of the session? And the answer to that is yes. So after this presentation, we're going to take the recording and package it up, and we'll send it to you in the next day or so, along with some additional resources that we hope you find useful. There would be a benefit to parameterize the work instructions for a family product. Can you speak to how you would follow the same work routing but change specific for individual SKUs? Yes, definitely. Go ahead.
So how you would follow the same work routing but change specifics for individual SKUs? So I mean, usually so you will have some maybe customizations within a work order. So I'm not sure I have the answer to this. Maybe Jen, you can take it. But once again, like those, this seems very specific requirements, which can be addressed like with, once again, the Tulip platform, like will allow you to build the process like based on your needs. So if you have like something specific about SKUs, then you can add this into the process that you're building with Tulip.
Yeah, sorry, I interpreted that as like what you showed during the demonstration where you had, different work orders coming in and then the instructions showed different things based on the different parameters within. So like, for instance, like the red knob will only show up for work orders that have red knob defined, and then it's like blue knob or is that, sorry, that's what
I realized I misread the question because I read work order instead of work routing. So yeah, you could have like the same route for multiple products, right? But having, for example, a different bill of material, for example. So actually exactly what you're talking about, where you can like require something slightly different or even a different process because you need to assemble, like maybe a sub-assembly is completely different and you want it to be managed by the process. So you can definitely handle this with the application. So those work instructions can be completely like parametered, right? Like based on the SKU on the product that you're working, the bill of material of the product, for example.
Yeah, and I mentioned this quickly at the beginning, but we have logic within Tulip, so you can set up different triggers so that it would go to like a specific step depending on like the specific thing that you clicked on, or like depending on like what's in the table as well. Awesome. Okay. Let's see if there's any more questions. So I don't see any. Oh, here, more questions here. Oh, just a comment. So I am an EMS subject matter expert. I see the potential in electric manufacturing processes. Yes, definitely. We have a lot of customers that are in electronics manufacturing. They are complex assemblies. Awesome. So.
And there's one more. So there's a question we see here.
Yes. What does the database use for the system?
So Tulip comes with like what we call Tulip tables. So it's something proprietary that allows you to store the data, right? So all the data collected can be easily stored inside our tables. And if you have, for example, like a database that you want to use, like we have what we call like a connector framework that will allow us to interface with any database, for example, right? So, and as we're talking about interfacing with third-party systems, we can integrate through like standard API calls, right? Like so modern technology for modern applications, but also like those SQL database connectors, so we can get the data directly.
Great, thank you guys so much for joining. Please feel free to reach out with any questions. Thank you.
Thank you very much.